Oh.
Hi, my name is Nidhi.
And my name is Basit.
Yeah, that's his name. And today we're going to be doing a physics project on
Gravity. Something about inclined plane.
talking about our project topic, free falling objects.
Yep.
Three identical masses are released simultaneously from a height h. Mass A is dropped from rest, mass B slides from rest down an inclined plane where friction may be neglected, and mass C is launched horizontally with a speed v0. Dominique and Carlos are trying to determine which block will have the fastest speed just before hitting the ground and which block will reach the ground first.
Well, I say that they will all have the same speed before hitting the ground. Remember that we saw this demonstration in class, and it didn't matter how the blocks were dropped, they all landed at the same time. The speed will also be the same because of conservation of energy. All blocks have the same gravitational potential energy to start with. This is the total energy that converts into kinetic energy.
Oh, I think you're mixing up time and speed. They won't have the same speed at the end because block C already has an initial velocity. They will land at the same time though.
Oh yeah? You think so clever, huh? I challenge you to an experiment to see which one of us is actually right.
Oh, it's on! So, to find out what's right and what's wrong, we'll be using a ball to test out the different scenarios one by one. We'll be using the same ball for the three experiments so that the mass will remain constant, and even though friction is still acting on the ball, it can be considered negligible as the rolling ball should overcome almost all the frictional forces.
Okay, so the materials we'll be using include measuring tape, electronic balance, feature board ramp, a ping pong ball, and of course a slow-mo camera. We'll want to make sure that each of these trials covers the exact same distance, so for the incline test we measured a 104.5 cm ramp equal to the dropping distance from the other experiments.
We'll be using our slow motion cameras to capture the time that it takes for the ball to hit the floor in each scenario. And then we'll repeat these trials until we can reduce the experimental uncertainty by quite a bit, so let's say 5 times. So, now let's see who's really correct. Spoiler alert, it's gonna be me.
The values that we'll be watching out for are mass, distance, and time.
Prior to the experiment, we've already measured the mass of the ball using an electronic balance, giving us a value of 2.8 grams. As mentioned before, the distance covered measures 104.5 centimeters or 1.045 meters.
For the first experiment, we will be dropping a ball vertically down with no initial velocity or ramp. 3, 2, 1.
The first drop took 0.7 seconds. Let's do that a few more times now, shall we?
The average time taken was 0.75 seconds. On to the next experiment.
Alright, so for the second experiment, we will be dropping a ball down a ramp. Let's go. 3, 2, 1.
The average time taken was 1.05 seconds, which is a bit longer than our first experiment, as expected, of course, since there were other forces besides gravity that are acting between the ball and the ramp.
Actually, no. As mentioned before, friction is negligible, so the real culprit is actually less gravitational force exerted vertically on the ball, meaning less acceleration and less average velocity.
Okay, so Now we're going to push a ball off 104.5 centimeters height, and we're going to do it 5 times in order to reduce uncertainty. The average time taken was 0.75 seconds, which is exactly the same average time as the first experiment. In conclusion, the law of conservation of energy can be applied because it is considered a closed system. Each block starts at the same height, which means that each block has the same value of the initial potential energy. I was correct on that, Carlos.
Well, I'm correct with the fact that the balls won't have the same final speed because block C already has an initial velocity. You said that the speeds would be the same when, in reality, they were not.
Well, you also said that they would land at the same time. Clearly, we can see that the inclined plane experiment had a 0.3 second difference to the other two.
In the end, they were both correct and incorrect with their statements. The masses had the same vertical speed, yes, but not the same horizontal speed. And the masses did hit the ground at different times, with A and C being the same, though experiment B being different. Oh well.